other questions. Next, we're going to hear from Amitabh Shrivastava. And he is a very talented engineer, inventor, and the creator of Programmable-Air. And I'm super excited to hear his talk. Amitabh?
Thank you for that introduction, Anthony. And thank you all for coming. I wanted to just give a shout out to my dad, who just joined from India. It's like 6 a.m. there. Hi, Dad.
Thanks for coming.
All right, let me share my screen and let's get started. I have like 53 slides. So this is going to be like a lightning talk, but I assure you it'll be fun. I think you guys can see my slides now. All right. Okay. Hello, everyone. I'm Amitabh. I'm a physicist turned engineer. Monday to Wednesday, I'm a senior hardware engineer at Aware, which is a building maintenance hardware startup. Thursday to Sunday, I'm a guy hanging out in his basement, starting new projects instead of finishing old ones, as we all do. Here you can see some of my tools, my mini lathe, table saw, drill press, welding machine, vacuum forming machine. I have like 3D printers, CNCs, laser cutter, and like so many parts full of bins. I like electronics and welding and VR and coding and woodworking. I don't like water sports. I think skydiving is pretty boring, but I do like building jetpacks to go skiing. And I'm also a total narcissist, and I would happily talk about myself for an hour, but that's not why we're here today. So why are we here today? Well, I'm here because Nate gave me this golden chance to share one of my passions with the community of inspired makers, and there's just no way I could pass up that opportunity. The passion that I want to talk about is soft robotics. So what's soft robotics, you ask? Soft robotics is the study of robotics with compliant materials. What's compliant? Materials that flex, that twist, that expand, and are a total nightmare to simulate in any finite element analysis kind of method. Now, all these things sound fun, but also bad, right? Because let's be realistic. If I were to ask you to make something like this, you'd use servo motors, not pneumatics, right? And I can't blame you, so would I. Soft robotics is pretty hard. So first, I want to convince you that soft robotics is interesting and worth talking about. So I would like to direct your attention to the ceiling, and I am going to hang out.
Amitabh, do you want to switch your screen back to your camera so we can see you up there? Too late.
I hope that was interesting to watch because it was very scary.
It was, but you were still on your presenter mode, so we could only see you on a very tiny screen.
Oh, okay. You may wanna like split screen me.
Are you going to be jumping back and forth a bit? All right, we can do that.
Yeah. So soft robotics allows you to make like grabbers that can pick up your bagels and cakes without smushing them. It can make a grabber that can separate yolk from an egg. It's pretty interesting. Or take young plants and plant them in a pot. But one of my favorite ones is this now defunct company called VersaBall, and they made this very interesting gripper. And you'll see a demo of something like this in a bit. But so you get it. There's a lot of grippers, which makes sense because you're trying to replace these very dexterous instruments we call hands in the assembly line, right? There's actually there's two main areas of the genome where humans distinguish from chimpanzees, and that is human accelerated region 1 and 2. Region 1 affects the brain, and region 2 affects the hands. So it's a big task if you're trying to replace hands, and soft robotic grippers are the best way, honestly, of doing it. But you can also augment the human hand, for example, by this iron hand by Bioservo, where they're using cables as artificial tendons to strengthen the grip of a user and avoid putting pressure on manual workers. It's actually powered by the technology behind Robonaut 2, the robot on board of the International Space Station. The gloves were developed by GM. There's also this inflatable knee exoskeleton from Rome Robotics.
For people, that's what I need.
Hi, Edward. This rehabilitation physical therapy exoskeleton from Rewalk, which is cable driven. And of course, there's weirder, more interesting stuff happening in research labs all over the world. But for my money, I like simple robotics. For example, this Grabo suction cup that some of you saw me hanging in the ceiling by. Do you guys want to see another demo of that if you didn't get to see a full thing? All right, let's go. It's kind of crazy, this thing. So as you can see this, it's essentially just a suction cup with a vacuum motor. But the guys, the team that created it spent a lot of time creating the perfect foam surface that will allow it to stick to rough surfaces like the drywall of the ceiling. So there's a lot of trial and error that goes into creating something like this. But when it works, it's really quite something. So I hope I've been able to convince you that pneumatic soft robots are interesting. And the thing that I find interesting about them is that it's very difficult to simulate something like this. This is a crawling critter that I created based on something similar by Howard. And to make something like this, there's a lot of trial and error. But to do controlled trial and error, you need a controlled source of air, which is why I created Programmable-Air. Programmable-Air is an open source hardware kit and the Arduino library, which is also open source, which allows you to control pneumatic soft robots programmatically. It has a couple of air pumps, 3 valves, a pressure sensor, along with some buttons and LEDs and basic I/O. It allows you to blow air into your soft robot and suck air out of it or let it exchange air with the atmosphere. The unofficial tagline is Programmable-Air. It sucks as well as it blows. As you can imagine, when I handed this easy to work with pneumatic controller to artists, they came up with some pretty weird things, like this heart by Julia Rich, one of my all-time favorites, or never before seen Lego frog by Joffé from RASD, or this sculpture by Kimberly Lin that doesn't like it when you get too close to it. But beyond art, there's also interesting engineering use cases for Programmable-Air. I actually used a Programmable-Air board to pick and place the assembly components to make dozens more Programmable-Air boards. And of course, the more practical use case of this is to precision place sprinkles on your donuts. And also you can use it to operate a jamming gripper like this one. And I have a demo of this here as well. As you can see, here I have a balloon and it's filled with coffee grounds. So it's quite flexible. But when I pull a vacuum, it becomes quite tough. And what happens is that the coffee grounds jam together and can't slide past each other. So whatever shape the balloon was in, it just gets stuck into a solid in that shape. So for example, I can use that to pick up this quarter off of a flat surface. And that's something an industrial robot would have a hell of a time doing. So I thought Programmable-Air was interesting and people agreed. So I crowdfunded the project in the summer of 2019. And it looks like a successful project now, more than $60,000 worth sold. But for a while there in the middle, it didn't look like it was going to succeed. It was less than half funded, and more than half of the time had expired. But I refused to spend any money on Google or Facebook advertising. I thought advertising was unethical. I'm not quite sure about that anymore. But what I did do is I just hosted workshops and presented the project anywhere and everywhere, just got talking to people about it. And it was a lot of fun. Some of the best memories I have from the summer of 2019 were of talking to people about this project. Here I'm hanging out with one of the co-founders of Arduino. So that's my lesson number one from manufacturing. Just talk to people and share your work. It's absolutely delightful when people go giddish, when you share your passion with them. And the free marketing comes in handy. Sometimes I find engineers scared to share their work because they're afraid someone will steal their idea. And I want to assure you that people have other things to do. I'm sure everyone in this room has about half a dozen ideas that they'd rather work on. But if you share your work, people will be all too happy to make connections, offer advice, and just overall motivate you to continue working. So please talk to people and create a community around you so that you don't have to struggle through your projects alone. Needless to say, the campaign was successful, and I got some money to start making a bunch of these boards. At the time, I was living in a smallish bedroom in Brooklyn, which was more tools and boxes than bed. And my brilliant plan was to make all 250 of these boards in my bedroom. Insane, I know. But I had some seemingly sound logic behind it. See, I'd spoken to a manufacturer in the US that will go unnamed, and they quoted me $70 per board to assemble. That's crazy, right? The board is simply not that complicated, and as I later find out, I could actually produce it for much cheaper. But at the time, I was right out of college, I didn't have a job. So I figured, well, even if it takes me an hour to build a board, I'd effectively be paying myself $70 an hour, which sounds pretty good. So I had hundreds of pumps and valves and Arduino boards and silicone tubes shipped to my house. And at this point, there was no room to walk around. Thankfully, I had actually been making dozens of these boards by myself for the workshops and such. So I knew I couldn't assemble the SMD components reliably in my PCB oven toaster. So I did get the SMD parts populated in China, but I still was planning to populate all the through-hole parts, connect all the tubes, test, and package everything in my bedroom. Thankfully, saner minds prevailed. And around that time, I got a job at Building Link. And my boss, Jerry, overall amazing human being, offered for me to assemble the boards in the office, which was insanely cool of him. So Jerry, here's a bouquet of USB cables to thank you. So I got to work laying out all the boards and populating all the through-hole components. And after populating came soldering, which was just crazy. And I made the mistake of using rosin core flux, which is a nightmare to clean. And sitting in front of the fumes every day for hours was just maddening. But somehow I did it. As you can see by looking at the windows, it's dark outside. I'm burning that midnight oil. But somehow I soldered all the 250 boards. But next came the silicone tubes. And Programmable-Air uses components that are just the cheapest possible. So the orifices of different components don't match. And the valves, it was an absolute nightmare to stick the tubes in. So huge shout out to my friends, Dani and Jesse and Arnab and Sid and MH, who really came through and helped me assemble these boards. I paid them, of course, but still I couldn't have done it without them. A friend once told me that 2 people are 3 times as fast at making something, and it's completely true. So again, please find your people so that they can motivate and help you. Well, once I had all these boards connected and tested, came packaging, which was a nightmare in itself. But looking at this beautiful row of packaged product, it was totally worth it. So what did I learn from this journey? Well, talk to people. if I hadn't spoken to Jerry, I would have been trying to juggle this entire project in a 10-foot by 12-foot room. I really, really cannot overstate this. People are really loving and helping beings. Like, maybe I'm the only idiot who doesn't understand this, but talking to people may be the most powerful tool you have. Secondly, make manufacturing a heavily front-loaded effort. Try to make systems and documentation so that someone other than you can follow them and make a quality product. Then outsource production. Please, please outsource production. Your mind and time is better spent creating other things than more of something. After the fiasco of the first production run, I did follow my own advice and I created lengthy documentation for my PCB manufacturer to assemble the entire board. So now I just get boxes of assembled boards, which I need to just ship and test. Of course, I'm still too lazy to do that, but that's another story. But the thing that I learned is also to shop around with your manufacturing partners. I thought that manufacturing these boards and assembling them would take $70 a board, but it turns out to be less than $7 a board, everything included in China, an order of magnitude less. Really, what I should be aiming for is to even outsource the testing and packaging so that the manufacturer can just put the thing inside the box and ship it to Crowd Supply, and the beautiful people at Crowd Supply can ship it to you. But in the meantime, I'm hoping to spend this weekend testing and packaging about 100 of these boards, which is still fine. So I've made a huge fuss about how people are important and you should talk to them. And there have been some amazing people who have really helped me through my life and career. And unfortunately, I didn't get a chance to thank them in these slides today because I'm rushing through. But here's the real way that I can thank them is to pay it back. So I'm a man of my word. If you're working on something interesting and you could use my advice, please reach out. I'd be happy to help you pro bono. I'm like Dumbo. I'm all ears. Thank you.